Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 2300 successful pair of spells and potion. So before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking that you are given three things: spells, potions, and the next one is success. So what you have to do is pick one spell, multiply with every potion, and check if it is what if their product is at least greater than the success. What at least means greater than equal to success. So let's take an example to understand much better. So this is the potion, not potion, the spell vector, and this is the potion vector, and this one is the success variable. So what we are doing, we take anyone, multiply with everyone in the potion, and see that the multiplication of that pair of those pairs is greater than equal to 7. So let's do 5 into 1 1, not 1, 5 into 1 5, 5 to the 10, 15, and this is 20, 25. How many of them are greater than 7? I will say 4. We take 1 and multiply everyone in the potion, so we will get this. Is there anyone greater than 7? No. So for the 1, I would say 0. If we take 3 and multiply with every one in the potion, what we get? 3, 6, 9, 12, and 15. How many of them are greater than equal to 7? So I would say only 3, these. So I hope you get what we are doing over here. So let me repeat: we take spell, multiply with potion, and check how many of that products are greater than the success for that particular spell. So let's understand how we gonna do it. So let's observe, we are given two things: spells vector, potions vector, and the success variable. Let's take one potion, not potion, why I'm always doing. Let's take one spell and one potion, multiply them, and what we seek, that this should be greater than or equal to success in order to be accepted. I hope this much is clear. Let's rearrange this. Spell. Now let's call this a value of x. So what we are doing over here is we are checking that if any of the potions are greater than and equal to x. We are finding that any potion is greater than or equal to x. Now this whole thing's boiled down to this, that if any potion is greater than or equal to x, we are finding something, that any one of the portion is greater than equal to x. Since we are finding something, which algorithm we will use is binary search. But instead of implementing binary search, we can do better. We can use one function, I would say lower bound. Why we are using lower bound is, if you read about lower bound, it will say it will return the iterator to the value which is greater than or equal to that value which we are finding. So let me again repeat it. It will return the iterator to the value which is greater than equal to the value which we are finding. So over here we are finding x. So we will get, this will give value something like this, and we are finding this. So why not use lower bound? I hope this much is clear why binary search and lower bound, and why we did this formula kind of thing, because you have three things in your hand. You cannot juggle between three things simultaneously. You have to have something concrete, boiled down to minimum things that you can take decision on. So we did minimize this to take the decision, and this is the intuition why we are doing this. And also you have to sort it, because it is nowhere written that portion is sorted, but in the test case it feels like they are sorted, but there is nowhere written that they are sorted. I hope this much is clear. And also we will take a seal value, a whole number, or if you don't want to seal, you can even use this success plus spell minus 1 upon spell. This is also a way which you can do to avoid seal. We are taking seal over here for obvious reason. We need that number, the whole number to search, not some decimal number to search. We need that whole number, so that's why we are doing seal. So this much is clear. What next? Let's write the algo, and there is one thing that is remaining. I will discuss that also. So what is the algo is, we will iterate on which portion of spell? I would say spell, because we are picking spell, then finding that X. So first thing, we iterate over spells. We take that spell, and what we do? Find X. We find X, then what we do? We find the index, not X, index using lower bound. This we will get a index, but one thing is remaining. How we gonna get that this much of pairs are greater than the success? So let's see how we gonna get that. Let's see. Let me erase it. How we gonna get that? Let's see. Let's take that test case and see ourselves what we will do. So let's calculate a X. We are taking 5 over here, so 5 plus 7 minus 1 divided by 5, it's 11. It will be something, but we are taking int, so we will have 2. You will say, what is the use? Let me show you the use. It will kind of 1 times you have to use seal. So just told you in a short. So what is X? X is 2. Portion is sorted over here. So what we did over here is lower bound. So what we will get? Value greater than equal to 2. So we have value that is equal to 2. We will get this 1. So what we will do is, we need to have this, and we are getting this, and we know this. Basic maths, just subtract this, you will get this. So this is how you will be getting. So length minus that index, to get that. What to get that? Total pairs. So I hope this much is clear. So fourth one is get the pairs, and when you get that, store in the answer vector and return that. After iterating, return that answer vector. I hope this was clear. Let's see the code, and I will try run also to have a better understanding. So this is the code. We are sorting. This is our result vector. Iterating over the spells. And what we are doing over here is we finding the need I wrote over here. You can also name it X. This is for overflow long, and this we get is what we get is the iterator. In the iterator, it points to the value which can be greater than or equal to that value over here need. So when we get that iterator, what we do, we just subtract it to the end. Portions end point to the n. What n means? To the end. So if 0 1 2 3 4, so n is this 5, so this is pointing to 5. So this minus this, so what we get, as I told you, the number of things or the number of pairs product greater than success. Yeah, we just push it, keep on doing till spells we have, and you just return it. Let's see the dry run, and this is the code, quite zoomed. Let's have the test case also. I have dry run it for 1. I'll be dry running it for 1. That will be 5. You can dry run. Let's dry run for everyone. We took 5. We find X. I am not doing line by line. We are finding X over here. How we find X? We have taken 5. So 5 plus success minus 1 divided by 5, we get 2. We find 2 in this. 2 3 4 5. We get this, and we subtract it 0 1 2 3 4, and we subtract it with what end. What end is 5 minus 1, we get 4. We push 4. Here it is 4 again. This time we took 1, and for 1 we do the same thing. We get 7, and when we will search for 7, 1 3 4 5, this is the portion. We will not get anything. We will get this end, and 0 1 2 3 4 5, we will getting this 5, and 5 minus 5, I would say 0 0. Now we are taking what we are taking 3, so we will again calculate that X, and it's 9 and it's 3, so we will check that in this portion vector, and what we get 2 over here, and what we do, 5 minus 2, I would suppose 3, and we have this inside this, and we just return it. And I hope this was clear. Let's try submitting it and see if it is running or not. Yeah, it is running, and I hope I was able to make my intuition clear, and if I was, so consider subscribing to the channel, liking this video, and sharing with others. And in the end, you have to do what you have to do, so keep grinding. You guys are awesome. See you in the next one. Bye bye. And also subscribe. Many people don't subscribe, they just watch with the video. So bye bye.